All right, so good afternoon again. We're going to pick off where we left off in the last presentation. So we started looking at the state space model, and we looked at what the state space model is, and we derived a state space model for an RLC network. And we're going to pick up right there. We will do a model for a spring mass damper system, and then we proceed to do or to look at how we move between the transfer function and the state space model. All right, so I'm going to now advance to the slides, or to the slide that we stopped in the last presentation. All right, so we did this one. Oh, I'm seeing a thing here. All right. I noticed that when I upload the slides into Blackboard, some of the characters or the features in the thing get deleted. So I'm going to have to do a different type of share. All right, so let me share the file a different way. So let's go back to here. All right, so let's do this one. All right, just confirm that you're actually seeing the slide.
Yes, sir.
Thank you. Right, so we did a state space model. In fact, let me go back to what the state space model looks like. This is the general format for the state space model. We have the state equation and the output equation, right? So this is the general format, and we discussed the different elements in this model: A, B, C, and D, which are the matrices, system matrix, input matrix, output matrix, and we also have the feed forward matrix.
We're not seeing the matrix, sir.
You're not seeing the matrix?
Yeah, not seeing the matrix.
Well, there's no matrix in it. We're just defining the terms. So there's
okay.
no matrix. Right, good. So we defined what a state variable is last week. So I'm not going to spend too much time on this. In fact, I'm not going to go back through this because we don't have much time. We're just going to move into continued analysis. So now we're looking at a spring mass damper system. And our aim here is to derive a state space model that relates the input, which is the applied force, F of t, and the mass displacement, X of t. So that's our objective, right? Now, you may recall when we analyze the spring mass damper system, when we're looking at transfer function, we were able to derive a differential equation that describes the system. Now, I'm going to ask if you can recall that, all right, where a particular law belonging to Mr. Newton is expressed here. Can anybody tell me what law is that? Or define the law? Did you hear the question?
Hello, sir. Can you hear me?
Yes, I'm hearing you slightly. Go ahead. You have a question or a comment?
Yes, sir. I'm not sure if it's on my end or yours, but I am seeing the state equation from transfer function slide.
Hold on. Yeah. You're breaking up a bit. Let me see. Is there a problem with the slide?
Yes, sir. I'm seeing the state equation from transfer function slide, and I'm sure that's not what you're talking about right now.
All right. I'm apologizing here, but part of what you're saying is breaking up. Could you just repeat for me, please?
What number slide are you on right now? The number.
Well, with the let me escape this. This is slide 11.
Okay, I was seeing 14 a while ago.
Are you still seeing 14 now?
No, I can see 11 now. Thank you.
What are you seeing now? Is it still 11?
State space, no, it's 11. State space module mechanical.
You need to
And I see the writing and recall that FTA minus.
But you weren't seeing that before?
No, was not.
I hope we're not having. I'm sorry. I'm really sorry. I'm not sure what was taking place. But let me know if it continues. All right. So we're seeing the annotations on the screen now. So we're reading, recall that f of t minus c dot x of t minus k of t is equal to m double dot x of t, equation 1. That's what you're seeing right now.
Yes.
Yes, sir.
All right, thank you. Let me know if anything goes away again. All right, so I was asking if you can recall what this equation or where it's coming from. All right, the thing with this now, I'm not able to see the raise and feature when I use this share method. As I said, when I upload the file into Blackboard, the equations get missing. So I'm going to ask that someone's away doing this, but just go ahead with your question, as I'm not able to see the raise and feature, please.
Sir, this is referring to Newton's second law, where the net force on a system is equal to the product of the mass and the acceleration of an object.
Thank you very much. That's exactly what is happening. So we're now going to seek to identify the different forces on the mass. So we know where we have the force F of t. We have force due to the spring, and I'm going to call this Fs, force due to the dashpot. And so this component here is speaking to the force due to the dashpot. This is due to the spring. This is the input force right here. And this is what we call the resultant.
You're writing on the screen, sir?
Yes, I am.
I'm not seeing that at all. No.
Okay. Who else is not seeing the writing on the screen?
I'm not seeing it.
So, for example, right?
Nobody sees it.
All right.
I left.
I just wrote on the screen. And what I just wrote?
No, sir.
No, sir.
Oh dear. All right. Okay, let's fix this.
Or is something just come on the screen a while ago? Don't know what you did, but we saw something.
You are now seeing something?
Yeah, it seems as if
Yes,
that
sir.
was what you were writing, but initially it wasn't there. So I don't know what you did.
When I put it into full screen mode, all right. You're seeing my entire application window, right? You're seeing the menu bar and so forth. Are you?
Yes.
Yes.
Sir.
Right. So when I go to full screen or to slideshow mode, something tends to happen. It's the first it's happening. I'm not sure why. So whoa, interesting. Whoa, I'm going to. Oh boy.
Sir,
Go ahead.
yes, I think it's similar to Zoom. So you probably would have to go on the full screen and then share the full screen. It's like when you're on Zoom and it's a different tab when you're sharing the screen. You understand what I'm saying?
So you're suggesting that I go to
You'd go
the full
to
screen first, but you see, when I do full screen, I'm not so sure. Go ahead, what you're suggesting quickly, please.
Yes, sir. So it's just like how you share this window thing, sir. we can see the menu and everything. I'm suggesting that you share the screen and that is I want to explain it right. Yeah, go to full screen and then try to share the full screen tab instead of the window one here. You get what I'm saying?
But when I go to full screen, I can't navigate to I can't navigate to Blackboard, you know, if I'm in full screen.
Yeah, so you would have to stop share first and then go to full screen and then share the why I think I'm confusing, but
All right, I appreciate the assistance, but I normally do it this way, and I'm not sure why it's happening this way. I don't want to shut it down and bring it back up. All right. It's good time the technology really, but it's something I do all the time. I just simply share. Let me stop and then bring it back up again. Hopefully that fixes the problem. Not sure why it's doing this. And I share the file. Not sure. All right, so I'm writing on the screen now. Are you able to see what I'm writing?
Oh, sir.
oh,
All right. Oh boy. All right. And when I share it, let me stop the